Hi, my name is Ashlyn. Welcome to the Microscopy and Imaging Center, a core facility supported by the Division of Research. Come on in. Stan is going to give you a tour of our facility.
Okay, welcome. Our first microscope that I would like to present to you is the Geo 2010 Transmission Electron Microscope, a 200 kV instrument equipped with a lab 6 filament as an electron source. It has a Gatan CCD camera, an EDS detector, and this is a microscope that is used mostly for materials analysis. It allows diffraction analysis. It's also equipped with a heating stage that can heat samples up to 1200 degrees C. It has single and double tilt holders, and it also allows elemental mapping using the Inca semi-stem mode. In this computer room, we have a workstation which has the Nanomegas A-Star and TopSpin software for data generated by the FEI TechNI Super Twin instrument. We also have the Oxford Aztec software for EDS data analysis from both the TEM and our scanning electron microscopes. And over here, there's another workstation, and this is used for data transfer and analysis of images from the Leica STED Super Resolution Microscope. So our center has 2 scanning electron microscopes, and the first one that I would like to show you is the Tescan Vega instrument. It's a tungsten filament instrument, so it does not have as high a resolution as the SEM that I will show you in a moment, but it's a really easy to use instrument. It's equipped with several different detectors, and I can point them out here. It has a secondary electron detector, it has an Oxford EDS detector, and there's also a retractable backscattered detector. This instrument has a computerized stage, fully motorized, and we also have the Alicona MEX software for 3D reconstruction of surfaces from stereo images and for analysis, for instance, roughness or texture analysis. The resolution is down to about 3 nanometers under ideal conditions. And now let's go look at our other SEM. So this is our field emission scanning electron microscope, the Quanta 600 SEM from FEI, or now Thermo Fisher. This instrument can work in both high vacuum, high resolution mode, but it also is capable of handling low vacuum or even partially hydrated samples in the presence of water vapor in the system, non-conductive samples. It's equipped with an EDS detector. We have a backscattered electron detector, a regular secondary electron detector. We also have the EBSD system, which is the HKL Oxford system, and a Gatan camera with RGB filters.
Yeah, so they have to start with 2, because otherwise
So this is our FEI or Thermo Fisher Techni Super Twin microscope. This is a 200 kilovolt instrument. It's equipped with Gaton energy filter. We have an EDS detector from Oxford and it also allows ultra high resolution STEM imaging in the dark field mode. The resolution is about 0.24 nanometer in point resolution, and it's equipped with Gaton cameras, actually 2 of those. The stage is computer controlled, accepts single and double tilt holders. And we also have a recently installed Nanomegas A-Star system and protochips heating stage that are available for our users. Now, allow me to show you our first, and you can stay where you are. This is great. Our first optical microscope of this tour. This is the Zeiss Lychee microscope. This instrument focuses a sheet of light within a sample to illuminate a single optical plane. That's then imaged on a camera. And it allows very high speed imaging or volumetric imaging, 3D imaging. The special stage on this microscope allows X, Y, Z and rotational control, and we have objectives that are both dry and also water immersion objectives, which can be then used for live imaging of samples. Besides live samples, we can also use relatively large, clear to transparent samples. We have 4 laser lines and a variety of filters for imaging on our 2 liquid-cooled PCOH CMOS cameras. In addition to the acquisition software, there is also an immerse analysis software as well as a number of open source analysis tools installed on this workstation. Our third transmission electron microscope is a Geo 1200X. It's a 100 kV microscope. So the resolution is less than with the 200 kV instruments, but it provides excellent contrast, which is very valuable for imaging biological samples, whether it's viruses, bacteria, or sections from samples that were fixed, embedded in resin and sectioned. And it's got tungsten filament. And we have a slow scan 3K by 3K CCD camera for digital imaging. In addition to biological samples, many of our users also use it for particle size analysis. They're larger nanoparticles or polymer samples and such. So in this room, I would like to show you several of our sample preparation tools. This is a Leica GP2 cryo-plunging apparatus. This is to prepare relatively thin samples, like suspension of viruses, liposomes, protein complexes. And this instrument has computerized the controlled blotting of the sample once it's applied on a special EM grid, and then it's plunged into liquid ethane so that it's vitrified without ice crystal formation. And it is then imaged on our cryo-TEM instrument that you will see in a moment. In addition to this instrument, we also have the Leica high pressure freezing apparatus. This is for samples that are somewhat bulkier because plunge freezing only works up to maybe several micrometers depth in a sample. In this case, we can vitrify the sample under high pressure at liquid nitrogen temperature, again without ice crystal formation. So this is considered the best possible sample preparation method for transmission electron microscopy. It avoids many of the artifacts that are associated with chemical fixation. Once the sample is vitrified, it is then transferred the presubstitution apparatus, where at approximately -80 or -90 centigrade, the water in the sample is replaced with solvent, typically acetone, without recrystallization of ice. And then this sample can be processed through regular resin embedding for sectioning and transmission electron microscopy. Speaking of sectioning, this is our Leica EM7 ultramicrotome, and you can actually currently see that it is equipped at this moment for cryosectioning. So we can section samples that are traditional samples that are embedded in resin and polymerized, but also samples that are either soft polymers that normally are very difficult to cut at the room temperature, or frozen or vitrified biological samples. Another, a much smaller accessory, but very useful, is this Pelka Easy Glow Discharge Apparatus. And this is used to render support film like former or carbon on the EM grade hydrophilic so that your aqueous sample disperses properly. So in addition to the ultramicrotome, we also have some tools for optical microscopy and histology. This is a regular rotary microtome that allows sectioning of wax-embedded samples. Typically, you would make sections several micrometers thick and put them on a slide. And these can be then imaged after staining, can be imaged on our optical microscopes. In this next room, we have some more sample preparation tools. This is a polisher, and typically these would be used for polishing samples for scanning electron microscopy. We also have a plasma cleaner for either cleaning samples, for instance, before some samples are put in the SEM or TEM, the impurities or contamination can be cleaned off. We can also use this machine for activating surfaces, for cleaning glass slides or cover slips, for high-resolution optical microscopy, and also for cleaning TEM holders to remove contamination. And over here is our pumping station that holds the Gatan cryo TEM holder. So these holders, when they're not in the microscope, they spend most of their life here, and they need to be kept under vacuum and go through the heating cycles so that they can perform up to the specifications. This is a diamond saw and a dimpler, and those are mostly related to material sample preparation for SEM or TEM. Continuing in the sample preparation theme, we have the fission and the ion mill, and this machine is used to thin materials before they can be put in the transmission electron microscope to sufficient thinness or thickness. And this is our second pumping station that's currently holding our newer Cryo TEM holder, the Fishione holder. And in addition to those, we also have some coders. This is a Cressington low resolution coder currently equipped with gold target. You can see the gold here. And this is to render samples for scanning electron microscope conductive and to achieve good imaging conditions. Another coder is used for higher resolution coding, so it's equipped with a different target, platinum palladium currently, and it also allows to use higher vacuum for the coding. And that's typically used in conjunction with our quanta field emission SEM. For cases where we need to apply a thin layer of carbon, we have a carbon coder instrument here. And now this is our Cryo TEM microscope. This is an instrument similar to what you saw previously, the Techni 200 kV instrument, but this one has a different pole piece orientation. So this one is called the Twin, and it has an anti-contamination device for cryo work, compute stage that allows tomography and accept single or double tilt holders and the cryo holders. It has resolution down to about 0.27 nanometers under ideal conditions, and it has the STEM mode with the dark field detector. We have a Gatan inline filter with a CCD camera, and in addition to that, we have a direct detection Gatan K2 camera, which is used for many of the cryo samples for low dose imaging to minimize beam damage to the sample. So now that we covered mostly electrons, let's look at some instruments that deal with photons. Our Olympus Flowy 1000 confocal microscope is equipped with multiple lasers, and it can also function as a regular fluorescent microscope. It's equipped with a sensitive CMOS camera. For confocal imaging, back here in this box, there are 3 detectors. Some of them are spectral, so that we can acquire emission spectra of fluorescent dyes and do spectral unmixing. We also have 2 high sensitivity gas detectors back here. So this microscope is used for imaging of either fixed or live samples that are biosafety level 1. And in addition to the regular mode of operation, we can also use the motorized stage to image multi-well plates or multi-well slides. And we also have the SIM scanner, which is an accessory that allows photo activation or photo bleaching at high temporal resolution. Now, if you don't need a confocal microscope, then there is this upright fluorescent microscope, the Leica DM6B. This microscope has a motorized stage, so again it allows image stitching, which is very handy for very large tissue sections on a slide. They can be imaged at a high resolution, or essentially the whole slide can be imaged and the images stitched together. It has 2 cameras, a monochrome high sensitivity CMOS camera and a color camera. It's got motorized filters, and the filters cover most of the common dyes or fluorescent proteins in the visible spectrum, from DAPI down to dyes like Psi5 at the red end of the spectrum. LED light source for fluorescence, and besides fluorescence, we can also do transmitted light imaging either in bright field, phase contrast, differential interference contrast, or in polarized light. Our last instrument that you will see today is in this room. And this is the Leica SP8 confocal microscope equipped with fluorescence lifetime imaging and STED super resolution. The microscope itself has an enclosure to maintain temperature, humidity, and CO2 for long-term live cell imaging. And related to that is this culture room with a biosafety cabinet and 2 CO2 incubators and cold storage for users' live samples. So these were all the instruments that you'll see today. But in this room, by the end of the year, we will have delivery of our new instrument, the cryo scanning electron microscope, focus ion beam, the Thermo Fisher Helios 5 instrument with Leica cryotransfer accessories. Adjacent to this room will be a sample preparation room, which I'll show you next. So this is the room for sample prep for the cryo SEM as well for the cryo TEM that is next door. So that was the tour through the MIC. I hope you enjoyed it. If you have any questions or if you have any projects that you will need help with, please contact us by email, call us, or visit us. We'll be happy to help you out. Thank you.